Hi, welcome back to PMT8002. So today we will start with normal distribution, which is chapter 5. So let's look at your learning outcomes for this chapter. Is when can you apply normal distribution? You need to know when when can you apply it and when you don't apply it. But you don't need to worry because the question already states it's normally distributed, so you pretty much know. Okay, the second learning outcome is to know the 68, 95 and 99.7 rule, which I will teach you as we go along, and learn how to sketch the curve with all the 4 important elements, how to calculate z-score and how to use z-score to compare. So in this video, I'll be going through all the learning outcomes in this chapter. All right, so what is normal distribution? So basically, let's just pull this a little higher. Just give me a minute. Okay, so what is normal distribution? It's basically a distribution that is reasonably symmetrical. This is what we learned in chapter 4, where you see a curve that looks like this. Okay, or the shape of the histogram resembles the bell curve like this. All right, okay. So as the sample size increases, the histogram will approach the shape of the normal curve. That means the more the sample size, then you can see it approaching it more and more. Okay, we usually actually use this to make predictions about where we expect most of our data to be. This is knowledge from chapter 4. Okay, so the keywords here are, this is also from chapter 4, reasonably normal. In chapter 4, you use the word symmetrical. So in other words, symmetrical simply means normal. All right. Then you have something that is approximately normal or somewhat normal. You can use either one. Okay, so let's look at this. What is the 68, 95 and 99.7% rule? 68% is 1 standard deviation of the mean. I'll show you what that means later. 95 is 2 standard deviations of the mean, and 99.7% is 3 standard deviations of the mean. All right, so let's look. This is your normal distribution curve. All right, so basically let me just show you what is important in this sector actually. Just give me a minute. Let me see if I can pull this a little higher. Okay, so this is your normal distribution curve. So if we look in our manual, I would be looking at this part now. Okay, so they've given you the mean. Okay, if you look in your manual, they've given you the mean is 100, standard deviation is 10. So you need to fill the corresponding values, which means you need to fill this part. Okay, so what we normally do is what I told you about the rule, the 65, 68, 95 and 99.7. These values are standard, it will never change. Over years of statistical research, statisticians have found that 1 standard deviation away is approximately 68% of the data. What is 1 standard deviation away? Right in the middle. What's right in the middle? I taught you all this in chapter 4. I sort of mentioned it. Right in the middle is your mean, median and mode. How do you have it symmetrical? Is when your mean, median and mode sits in the middle. So your mean is always in the middle. All right. So like in this part of the question, they've told you the mean is 100. So if the mean is 100, so your mean should always be in the middle. All right. And as you move to the right, you keep on adding. As you move to the left, you keep on minusing. It's just like a normal number line. Okay, so right in the middle is 100 because that is your mean. What's the standard deviation? 10. So as you go to the right, you keep adding 10. So 100 plus 10 plus 10 plus 10. Then here is minus 10, minus 10, minus 10. All right, so when we say 1 standard deviation away is basically this part. 1 standard deviation away is minus 10 and plus 10 is what we say 68% of the data lies between 1 standard deviation away. Between 2 standard deviations away, 95% of the data lies. Within 3 standard deviations away, 99.7% of the data lies. All right, so what I was talking about is the 4 important elements. Actually, not all 4 are important, just 3 will do. The percentages, your values, okay, the percentages, your values, and z-score. What z-score? When I say 1 is 1 standard deviation above the mean. When I say -1 is 1 standard deviation below the mean. When I say 2 is 2 standard deviations above the mean. When I say 3 is 3 standard deviations above the mean. -2 is 2 standard deviations below. -3 is 3 standard deviations below. Okay, so these are the 3 things you must have when you sketch your curve. So right here, what you're going to be doing for me is just filling up the values here. That's it. All right, so let's look at this. You may need to fill up this part. Follow my video, yeah? So what is the difference between the curved bracket and the squared bracket? The curved bracket like this doesn't include 90 and 110. The square brackets like this includes 90 and 110. All right, so the curved brackets do not include 90 and 110. The square brackets include. So what you are going to be using now when it comes to normal distribution is the square brackets. All right, so let's look at this curve. I think right now we are here. I want you to fill up all these sections. How do you fill this up? So if you know this is 68%, what would this and this be? You just divide by 2. So right now we're actually at page 1 to 5. I want you to complete that. So if you can try to pause my video, try to complete first, then you play it. Because a lot of you would make mistakes around here. Like here it's very obvious. Oh, 68 divided 2 is 34, 34. How about these two? How do you find these two? So we've got to actually take 95 minus 68. That balance you divide by 2. Okay, a lot of students make a mistake by saying, oh, it's 95 divided 2. No, you have to take away the 68 first. All right, so this would be the values that you would get. All right, these would be the values that you would get. 34, 34, 13.5, 2.35, and 0.15. As you go along, you will start remembering the numbers, but for now, as we're doing the questions, it will be really good if you can actually just write the values down. Okay, all right. Okay, so let's look at example 1, which is on page 126. All right, so example 1, the length of human pregnancies from conception to birth varies, which varies according to a distribution which is approximately normal. Like I told you in the questions, they already tell you it's a normal distribution with a mean of 266 days and a standard deviation of 16 days. All right, so pretty much even when you do your exams, they've already given you this curve. All you have to do is fill it up. What I told you, what are the 3 most important things? Write your percentages: 68%, 95%, 99.7%. And then you got to fill up Z-score: 0, 1, 2, 3, -1, -2, -3, and the values. These are the 3 most important things actually. If you ask me this part, no, not really needed. Okay, so let's look at part A. Sketch a normal curve. The curve is already done for you. Shows the duration of most pregnancies, which is the values. So the first 2 will be basically filling up the values for me. So 68%, 95%, 99.7%. Please follow exactly the way it's done here, right? Please don't go put your arrows from different place. Okay, then your normal Z-scores, like I mentioned earlier, 1, 2, 3, -1, -2, -3. What should be right in the middle? The mean. They've given you in the question, right? The mean is 266, standard deviation is 16. So 266, as you go here, you plus 16, plus 16, plus 16. Minus 16, minus 16, minus 16. So between which 2 values do the lengths of 99.7% of all pregnancies fall? Between 218 to 314. So we are going to use the square brackets because we are going to include 218 and 314 because it is from 218 till 314. So you're going to include that into your basically into your comment. So that's why you use the square brackets. If you don't want to use these brackets, then you actually got to write it down in full, you know, like this: 218 days till 314 days. This is, I think this is a lot more work compared to using the brackets. All right. How short? When we are talking about short pregnancies, we are talking about this part. These are long pregnancies. These are short pregnancies. 2.5% of all pregnancies. So now you want to find 2.5%. I'm just going to go back here. So if you're talking about short pregnancies, you're talking about this part. So this is 0.15. This is 2.35. You add both of it up, you will get 2.5%. So this 2 is 2.5%. So less than 234 days. All right, you'll get the hang of it slowly. If you cannot remember this, I would suggest just write it down. When you're drawing it, you write it down: 34, 13.5, 2.35, 0.15, 13.5, 2.35, 0.15. So when they ask you questions, you can actually add it up directly. Approximately what percentage of pregnancies? Approximately. So the moment you see the word approximately, you pretty much know the number 250 and 300 won't be in here. It won't be there. Okay, so where is approximately 250 pregnancies? Here. 300, which is the closest number to 300, this. So you got to add all these values up. All these percentages. Basically all these percentages here. So if I were you, I'd rather write down, then you can actually add up 34 plus 34 plus 13.5. And you will actually get 81.5. It's up to here, isn't it? So you'll get 81.5%. Okay, so we are pretty much done with this. So now we will be covering Z-score in your manual. So if I were you, I would do this question first, pause the video, and then move on. Okay, so now let's look at Z-score. So far the Z-score we have looked at is all very basic. If you look at 1, what is 1? Okay, 1 is 1 standard deviation above the mean. If you see -1 is 1 standard deviation below the mean. 2 is 2. So what if you have something like 1.35? How do you get something like that? So this is what we're going to do now. So what is Z-score? Is a standard score. It indicates how many standard deviations above or below the mean. If it's above the mean, it's positive. If it's below the mean, it's negative. In other words, it is the actual distance on a standardized scale of how far that value is from the mean. Okay, so there is it's a dimensionless quantity, therefore there will be no units for Z-score. All right, so how do you find Z-score? You take your data minus mean, divide standard deviation. You take your data minus mean, divide standard deviation. All right, don't worry, this formula is actually given to you in your exams. Okay, on an approximately normal distribution, the mean and standard deviation can be used to infer how extreme any data could be. Okay, the bigger the Z-score, the data is further away from the mean. Like my Z-score is 4 or -5. You can pretty much see it's very far away from the mean, meaning you know it's pretty extreme. That means the further it gets away, the more extreme it is, the more unusual it is. Okay, you can actually use it to compare two different sets of data to see whether is it extreme or is it not extreme. Okay, so if you look at this, if the value of Z-score is big, is far away, more unusual. If it's small, it's closer to the mean. You can ignore the negative sign when we talk about big and small, right? Okay, you always look at the scale. The further it gets, the closer it gets, the better it is. So this is what it means. When the Z-score is small, is closer, is more likely to happen. If it's big, it's far. If it's positive, above, negative, below. I've already explained that. So let's look at example 2. In this case, example 2 is right here. How unusual is it? All right, so let's take a look at this. So let's look at case 1. Your mean is 60, your standard deviation is 10. The weight of the egg is 70 grams. So how to find the Z-score? I told you what? Data minus mean divide standard deviation. Therefore, you take 70 minus mean, which is 60, divide by 10. You will get a Z-score that is 1. What does that tell you? That's 1 standard deviation from the mean. Case 2, you got 60 and your standard deviation is 5. The weight is 70. So you got to find your Z-score. 70 minus 60 divided by 5. Your Z-score is 2. So this is 2 standard deviations from the mean. So the bigger the Z-score, the more unusual. So as a standardized score, case 2 is bigger than case 1. That means the egg in case 2 is considered more unusual than the egg in case 1. All right. So let's look at example 3, which is here. The weights of a manufactured CD are known to be fairly normal. See, I already told you they'll actually mention it. So you pretty much know you have to use the normal distribution. with a mean of 14.1 and a standard deviation of 0.3 grams. So particular CD is sample and weight and found to be 12.9 grams. Convert these to Z-score. So how to convert to Z-score? Data 12.9 minus mean divide standard deviation and you will find the Z-score. So what is the Z-score? -4. Okay, so it is extremely light. When it's negative, it's below the mean. You pretty much know it'll be on the light end, not on the heavy end, as is well below the 99.7% of all CDs. Or in other words, you can actually just write it is quite unusual as it is further okay, you can write it that way as well, that's not a problem. Okay, either one. Okay, the one in red is actually a more appropriate way to answer, but this is a teaching slide, so therefore it'll be more appropriate. I'll be more in full. All right, well below the 99.7%. What are we talking about? Is this one below the 99.7? That means it's out here. All right, because up to here is 99.7, so they're saying is way below that. Okay, what weight corresponds to a Z-score of 2? Now what are they doing to you? They're giving you the Z-score and they're asking you to find the weight. So 2 equals to you don't know minus mean over standard deviation, and the weight will be 14.7 grams. All right, so basically that's how you find it. Okay, so now we are going to actually fill up this curve. That shouldn't be a problem, that should be quite direct. Fill up percentages first, 68, 95 and 99.7%, and then you fill up all your Z-scores. All right, fill up all your Z-scores, and then you fill up the values, your mean, then you add 0.3, add 0.3, add 0.3, minus 0.3, minus 0.3, minus 0.3. Okay, find the values between which you expect 68% of the CDs to lie. Okay, 68% and 2/3 can mean the same thing. All right, 68% is actually 2/3. So if they mention the word 2/3, it also means 68%. I want you to get used to this. Okay, all right, so now what is it between? It is between 13.8 and 14.4. So if I were you, I would rather just use the square brackets. If not, you have to write like this, between 13.8 grams and 14.4 grams. So if you use the square brackets, you don't even need to write units, you know, it's a lot easier. Okay, so you're only going to accept between -3 and 3. So what would be the accepted weight? 13.2 to 15. That's pretty direct. All right, so you see, you don't need to write this. You can straight away just put down the square brackets. When they ask you proportion, they're actually asking you for percentage. So what proportions of CD would you expect to weigh more than 15 grams? So this is 15 grams more than that. How many percent is this? 0.15%. So in a sample of 3,000 CDs, how many would be? So you don't forget, you have to take 0.15%, which is 0.15 over 100 times 3,000, you will get 4.5. You can't have 4.5 CDs. You round off to the nearest whole number. Follow normal rounding rules. It will be 5 CDs. Okay, so now we'll go through exercise 5.1. I'll go through the ones that are quite direct quickly. Okay, so a data set is bell-shaped. They're given you the mean and standard deviation. What values would you expect 68, 95 and 99.7% to lie? If I were you, before you do ABC, you better draw the curve first. You fill up the curve, fill up all the values, then you would be able to answer actually. See, if you fill up all the values here, you'll be able to see directly which is what to what. All right, so this is quite direct. You should be able to manage this. Okay, question 2. Are asked to estimate the length of a 30 cm piece of string. So the length of the string is actually 30 cm. You're actually estimating. That means you're looking at the string and guessing, oh, it's 45 cm or something like that. So the result is fairly normal. The mean is 30. Standard deviation is 3.5. Fill up the curve. This is what the curve would look like. All right. You have it in your slides as well, okay? But you can pause and play my video as you go along. That's fine. Okay, so this is fairly how it should look like. Your 68, 95 and 90. If I were you, I'll write down these values. It'd be easier for you to answer the question. Your Z-score and your values. Okay, what percentage would we expect to overestimate? When I'm saying overestimate, right, you are saying it is longer than it originally is. All right, that is overestimating. You're saying it's longer than it is. So now you're overestimating by at least 3.5 cm. Okay, so the mean is 30 cm. You're overestimating by 3.5 cm. You're saying it is 33.5 cm or longer. So 30, you're overestimating by 3.5. That means you're saying it's longer by 3.5 cm. So you're overestimating, meaning you're saying it's 33.5 cm or longer, meaning this part. How many percent would that be? 13.5 plus 2.35 plus 0.15 gives you 16. That's why I say if you write this down would be better. Just now I taught you 2/3. So which two estimates would you expect 2/3? 2/3 is 68%, which is actually 26.5 to 33.5. You don't need to even write the cm if you have the square brackets already. Between which two estimated lengths would we expect virtually all? What's virtually all? 99.7%, which is 90.5 to 40.5. So these are the two new terms that you need. 95% got nothing. 68 is 2/3. Virtually all is 99.7%, which is you can see it in this when as you go through the slides, right? It's actually here. I've put it here in the slides, okay? Virtually all is 99.7% and approximately 2/3 is 68%. Okay, if we could sample 10,000 students randomly, how many of these would we expect to estimate a land which was greater than 3 standard deviations from the mean? If from the mean, again, I'm going to stress this because students always make mistake, is both sides. From the mean is both sides. So 0.15% plus 0.15% gives you 0.3%. So 0.3% of 10,000 is 30 students. Okay, from the mean is both sides. 3 standard deviations above or below only one side. So above only one side. All right, 0.15% of 10,000 students. Okay, question 3. This is also quite direct. I would expect you to manage this pretty well. Okay, except for the last part. They would ask you, if a woman aged 20 and 29 has a height of 2 meters, how many standard deviations is that? This one, they're asking you for Z-score. When they ask you how many standard deviations above or below the mean, they're asking you to calculate Z-score. So you need to calculate the Z-score. So you need to change this to cm because everything here is in cm. You change it to cm and you just find the Z-score. This should be quite manageable. The whole question is all very... Chapter 5 is very repetitive and actually quite an easy chapter. The one with the least calculations. Okay, same goes to question 4, actually quite direct. 2/3 is 68%. What percentage of men are taller than 197.3? How many standard deviations you're actually finding Z-score. Okay, and then this one you're finding percentage and just multiplying it. Shouldn't be a problem. Okay, so let's see, question 2. Question 3, question 4 is also manageable. Question 5, same thing, very manageable. They've given you the mean and standard deviation. You fill up the curve. When they ask you what proportion, they just want percentage. All right. This one, let's look at this question. This is a little bit different. Okay, they've given you the weights of different CDs in a sample. So you've got to sketch the normal distribution curve. As usual, the 3 things, you fill up your Z-score, the values and the percentages. Now convert each of this sample weights to Z-score. So that's all. You just need to change it to Z-score. So you take 12.9 minus mean, divide standard deviation. 15.1. So you do it one by one. Change it all to Z-score. 15.1 minus mean divide standard. Change it all to Z-score. Then you're just going to rank it from the most extreme to the least extreme. What is most extreme? Most furthest away from the mean. Which is the furthest away? Don't look at negative and positive. Look at how far away is it. This one, right? 4.75. So you start with S3. Then you have S1, S2, S4 and S5. So you look from how far away. Don't look at the negative and positive, okay? Look at how far away is it. All right. And this is pretty much quite direct. Let's look at question 7. It's an IQ test. So you just write the Z-scores, calculate the Z-score between which two is 99.7%. You want to draw the curve and do, you can, but if without drawing also you can find, it's no problem. Which is more extreme? So how to find which is more extreme? We find the z-score of both. You find the z-score of both and you see which is further. So this is further, so this is more extreme. Don't look at negative and positive. Always look at which is further. Alright? Same goes to this. Is this unusual? So you're going to find z-score. This is negative 3.06, which is quite far away from the mean. So we would expect it. You can just straight away say it is quite unusual. Same like earlier, the comment. Yes, it is further away. Also can, no problem. You can answer like that. So this one is just from the percentages here. That's not a problem. Okay. The heights of women. So this is also, which is more extreme. You find the z-score and you just comment on which is more extreme. Alright. Is it possible to have something like that? You calculate the z-score. You will get a z-score of 8.33. You cannot say it's impossible. You just say it's highly unlikely. Alright. Okay, so this one we got to read the question. This is a bit different. Okay, the available playing time of a so-called 3-hour videotape. So the advertised playing time is 3 hours, which is 180 minutes. There's a mean of 190 and a standard deviation of 5. So from your manual, let's see if they've asked you. If I were you, I would sketch this first. Because if you sketch this first, you can see things more clearly. Alright? A particular videotape is sampled and found to have a playing time of 213. Convert this to z-score. So just change to z-score. 213 minus 190 divide 5, you will get 4.6. Z-score should always be in 2 decimal places. If it's in 1, then it's fine. But if it's 2, you leave it as 2. It's very extreme and further away from the mean. You can just comment like that. What time corresponds to a z-value of -2? Now they're telling you the z-score is -2. They want you to find the data. We've done one question like that, so just plug it into the formula. It will be 180 minutes. What does that mean? It has the advertised playing time. The advertised playing time is 180 minutes. Alright? What proportion plays less than the advertised playing time? Advertised playing time is 180 minutes. So less than 180 minutes, how many percent? 2.5%. 68%, just write the values down. Quality control staff at a factory suggested that only tapes within -3 and 3 is going to be accepted. So they are only accepting between -3 and 3. So what's the values? 175 to 205. How many batches is 2,500? Tapes would expect to play less than that many hours. So you change the hours to minutes, you will get less than 175 minutes, which is this 0.15%. You times 2,500, you'll get 3.75, which is approximately 4. Okay, so that's about it for chapter 5. Basically, it's pretty much a short chapter, not a very long chapter, and a very repetitive chapter. Okay, so you should be able to complete these exercises. It shouldn't be a problem at all. Okay, so if you have any questions, please do ask me. All right, so please pause and play the question as you're doing the questions. Pause and play the video. Pause it, do it, and then you can play and check it. All right, so I've gone through all the questions one by one.